Hello everyone, in this video I will be discussing the bachelor thesis topic titled Intelligent Radio Resource Management (RRM) in ORAN, Open Radio Access Network based 5G and beyond networks. So in order to start this, let's give a background on what is called Cloud Radio Access Network, which is what is before ORAN. So CRAN, in order to understand it, let's start from a base station. So a typical base station would look something like this. So you have the tower, and then on the ground, if you notice, you will have some cabinet where we have all the equipment. And essentially, the base station could be seen as two components. We can see it as an RRU and a BBU. Okay, so an RRU, which is a radio resource unit, and a BBU, which is a baseband unit. So this is what receives signal, the RRU, and the baseband unit is what processes this signal before sending it to the backhaul of the network. And as you have learned in mobile communication, then we have multiple cells. Each cell could take a hexagonal shape, and it's responsible, and one base station is responsible for one cell. Now, the idea of a cloud radio access network is that while the RRU units, so these units have to be physically located in this particular location to represent this cell, actually the BBU do not have to be located there. So instead of having the BBUs and all the energy consumption, all the infrastructure, and all the necessary equipment to have it in this location, then we can throw them to the cloud and connect them by a network or by a connection to a cloud processing unit. And therefore, the cloud is hosting the BBUs, and we have separated the RAN into the BBUs and the RRUs that are no longer physically located or co-located together. Now, the idea of Open RAN, which is the next generation, means that this interface, in order to communicate between here and there, between the RRU and the BBU, there is a protocol for that. And this protocol in the CRAN is proprietary. It means that Ericsson has his own protocol, Nokia has their own protocol, and so forth. Now, the word open means that the protocol between RRU and BBU is open, and this creates an avenue for interoperability between different vendors and operators. So different operators can use the BBUs of each other, can use the cloud virtualization tasks of each other, and so forth. And also, cloud radio CRAN and in general, and ORAN in particular, opens a great potential for inserting network intelligence, and this is where our project will try to work on. Now, our objective in this project is to use some open cellular traffic dataset. So this is a dataset that is publicly available, where we can have information from multiple base stations, real base stations, and the amount of traffic that are required within, I think there are 37 base stations. The amount of traffic, we're talking about the IP throughput, the resource utilization, so what's the percentage of resource that are utilized from the respective networks or required from the respective networks. And why do we need this? Because one of the ideas of intelligence resource management says that what if we have at some point of the day, maybe it's off rush hour, that this base station over here, the traffic in this area is very low, such that we can switch off, or we would like to switch off this RRU and BBU. So they are dimmed now. So because the low load, we don't want to pay the penalty or the energy consumption affiliated with. So let's say that this is designed to support maybe 100,000 subscribers, and at this point of the day I only have 10,000. So why should I pay all the energy consumption needed to support these users? I'd rather intelligently learn this, and in order to compensate, I can play with the amount of transmission power of these two RRUs to extend the range, such that I can support these 10,000 users, which is a relatively low load to add to the original cell. So this was the original cell. So I expanded by increasing the communication range or the transmission power of these two RRUs. In order for this idea to work, then you need to have the intelligence to be able to use machine learning to predict traffic congestion. So you want to know when will this happen and when should I apply my optimization schemes or my radio resource management schemes. So what we will do in this project is that we will take this open cellular traffic data set, we will apply machine learning to it to predict the times or the interval of times where there will be congestion, and then we will be proposing our schemes on how to manage the radio resource scheme. Should we expand the cell? How big should we expand it? And which BBUs should we switch off? Which BBUs should we extend, or which BBU RRUs? Which cell should we increase its range? How much should we increase its range by? And we will do the evaluation of this by using a simulation model. This project, we have been approached by Dell Egypt. They are quite interested in this type of projects because they are building a team inside Dell with the objective of building their own ORAN platform. So they are quite interested for graduates to have the know-how of these technologies. So that's why they are interested in this project. What are the tools that we will be used? We will be using Python and machine learning. An example of tools in this paper that I am showing over here. They're using neural networks to do the prediction of congestion. And therefore, it would be nice if you're interested in this project, to check this reference. So Intelligent ORAN for Beyond 5G and 6G wireless networks. This is the link for this, but if you search by the name, you will be able to find it easily from Google Scholar. So this provides an overview of this project. Thank you for your time listening.